Alright, so I'm going to be going over 4.3, number 7. Determine if the matrix A is invertible, and if so, use the adjoint matrix of A to compute the inverse. So, the first thing we need to determine is if it's invertible. So, in the book, it states that if A is invertible, then the determinant of A should not equal 0. And so, I did that on the... So, that's the first thing I did on the left. So, first, I just used turned it into the matrix into echelon form. And then from there, I just multiplied the diagonal entries, which is seen right here. So I got 2 for the first one, and then negative 1/2 for the second diagonal. And so I just multiplied them together, and I got negative 1 for the determinant, which is not 0. So it is invertible. And so from there, I just find the adjoint matrix. So the adjoint matrix is essentially just the each entry is going to be the cofactor the cofactor when you remove the corresponding row and column. And so and I show that on the right, where I got the cofactor of removing row 1 column 1 would be 7. The cofactor of removing row 2 column 1 would be -5. The cofactor of removing row 1 column 2 would be -3. The cofactor of column 2 and row 2 would be just 2. And so the adjoint matrix also states that it would be the transpose of these corresponding entries. So before the transpose, so we got would give you this matrix right here, where 7 would go into row 1 column 1, -5 would go into row 2 column 1, -3 would go into row 1 column 2, and then 2 would go into row 2 column 2. The transpose would be the following matrix right here. And so that would be the adjoint matrix of A. And so in the book, it states that the formula to find the inverse would be multiplying 1 over the determinant of A, multiplied by the adjoint matrix of A. Yeah. And so I would just substitute the values that the corresponding values, and so it would just be -1, since 1 over -1 would just be 1, times the adjoint matrix of A, so it would be right here. And so essentially, it would just be swapping the signs, and so this would be the inverse of A, and that would be the answer.